Okay, students, I'm going to go over your practice test here. Explain each of the problems, so you should be good to go for your test next class. All right, so remember, when we have a standard equation of a circle right here in number one, we should remember the three key words. Let's change the color here. Opposite, opposite, and square root. So the opposite of -4 is +4, the opposite of 8 is -8, and the square root of 9 is 3 for the radius. Remember, this is r squared always right there. Right, the equation of a circle with center. So now we're going the reverse direction. They give you the center and the radius. They want you to put it into the standard form like number one. So remember, it's still the same thing. It's going to be opposite. Instead of square root, we're going to square it because remember, it's r squared. So we have x minus 3 quantity squared plus y plus 2 quantity squared equals 2 squared, which is 4. Graph the following. Again, we like opposite square root. That's why we have 2, -2 with a radius of 1. So plot 2, -2 and go 1 in each direction, north, east, south, and west, and do your best to connect it to make a circle. Number 4, most missed on the test, is completing the square to find the center and exact radius of the circle. So exact means radical, if need be, no decimals. Okay, so you don't put in a calculator and give me a decimal unless it came out nicely, you know, like 5.2. If it came out exactly that, or 2.5, exactly that, but no, otherwise no decimals. Should be in radical form. Okay, and that's how it'll be on the DCAS. All right, so remember, we want our x squared and our y squared to be positive. Well, y squared is already positive on this side, so that means we're moving everything to the left side, except for the constant we'll leave over on the right side. Okay, so and then we arrange our x's together and our y's together. So you have x squared, and then plus 14x becomes minus 14x, and I do plus blank. Okay, because we need to fill that in, and then I have plus y squared plus 8y, because the opposite of minus 8y is plus 8y, plus blank equals our -2 plus blank. So whatever I add on the left side, I must add to the right side to keep the equation the same, equal, without changing it. And then where do I get the plus blank? The c. Remember, that's solving for c in both of these. It's always 1/2 of b. C equals 1/2 of b squared. And remember, a is the one there, the coefficient there, b is this one, and c is what we're solving for. So half of b, half of -14 is -7 squared, and that's 49. And I do half of 8 on the next one is 4, positive 4 squared is 16. And so I really added 65 to the left side, so I add 65 to the right side. So now when I factor the x squared minus 14x plus 49, it's going to factor nicely. That's a perfect square trinomial from Algebra 1. And that's x minus 7 quantity squared. As I've told you before, you can just simply, if you've done the 1/2 of b correctly, that will always be right there since our leading coefficient is 1. And then I can drop this 4, same sign, positive there. Again, remember, it's always going to be the sign of the b term. So if you somehow screwed up, make sure you're checking to see if you have the same sign as that b term. Okay, and 65 minus 2 is 63. Okay, now we have it in standard form, just like number 1. So we're doing opposite, and square root. So I have 7 and -4 for the center, and I have to break down the square root of 63. Remember, we're looking for perfect squares that go into it. Perfect square goes into 63 is 9. 9 times 7 is 63, and that breaks down to then 3 roots 7. And that's why you see that right there. I've already sent you a video on reducing or simplifying radicals. If you need more help on that, go back and watch that video, or you can just type one of those into YouTube and say simplifying radicals. And you can get one off of there. All right, number 5, write the rule to describe each transformation. Okay. Now, at first it might look like it's reflected directly across if I split it there, but it's not. Okay. Because this reflects down here and it should have reflected to there. So I was just drawing that to see if at first, if I split it, if it would work. It does not. So one of the things I'm looking for is I see that the triangles are in opposite quadrants, quadrants 2 and 4, as we see here. Remember, that's 2, 1, 3, and 4. Okay, and since they're in opposite quadrants, there's a good chance it's a rotation of 180 degrees. Remember, it doesn't matter if you said rotation 180 or rotation negative 180, same thing. You're going halfway. And remember, if it is a rotation of 180, it's going to go right through each. When I connect the pre-image point, the image point is going to go right through the origin. We see that going right through the origin and the same distance, because don't forget, distance is preserved. This one going right through the origin goes right there, and this going right through the origin goes right there, the same distance. So it's just a rotation of 180. Remember, I can use capital R for rotation, and just say 180 like that as well. If you don't write, if you do not want to write out the word rotation 180 or negative 180. Right here, 6, I should be able to see that's a slide, because I'm just going from here down to here. So I write a translation rule. Remember, it always starts with x, y, x comma y maps onto. And what did I do? I went plus 2 in the x. I went minus 1 in the y. So it's x plus 2 comma y minus 1. And I can check that if I wanted to for each of the other corresponding points, and that would work out as well. Okay. So by the way, on DCAS, you want to make sure if you're thinking of translation rule, you want to make sure you check 2 points. Okay. And if it works on 2, it's good to go. Sometimes it might work for 1 if you happen to pick a right one, but it ended up being actually a rotation. Okay. So if you're not confident it's a translation, check on 2 points, make sure that same rule applies for 2 points, and it will. It'll apply for all 3. All right, 7, graph the pre-image point to negative 3 right here. So it says A, and then we should automatically recognize that as a translation rule. We just wrote one right before right here. Okay, and oh my goodness, look at that. It's the exact same one, x plus 2 and y minus 1. Okay, so again, that just means write 2 down 1. And there's my A prime. And go ahead and write that over here. Remember, I can just plug the x right into there. 2 plus 2 is 4. And the y right into that, y, negative 3 minus 1 is negative 4. So it should be plotted at 4, negative 4, which it is. Okay, so like I told you in other worksheets, I suggest you do it on the side here with the numbers first and then go ahead and plot. This was easy enough, it's no big deal, but I'm saying for these other ones. For example, doing it with 10, like I did over here on the side. All right, number 8. We're drawing a triangle and then reflecting over the line y equals 2. You need to know from Algebra 1 in pre-algebra, when you graph the lines, that y equals 2 is a horizontal line going through the 2 on the y-axis. I plot the points and then I count how far it is to that line and go the same distance up. So 3, 2 is right on the line, so it reflects right back on itself. 3, negative 1 is right here. And I count up 1, 2, 3, so I'm going to go up 3. 1, 2, 3. That puts it right there for B prime. B. And C, negative 3 is right here. I count up 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 would be up here for C prime. And then I go ahead and reconnect those. And there's my image triangle right there. Number 9, find a rule that describes the translation. So it's telling you it's a translation. So that means we're going to write a rule just like this, but going from point Z to W right there. So I always start with x comma y maps onto. How do I get from Z to W? I go right 2. That's positive 2. I went, and then I went down 6. So x plus 2, because that's the x direction, and down 6 is with the y. So y minus 6. There's your answer. All right, rotate 270 degrees counterclockwise. So that's positive 270. It's positive 270. It's the same thing as negative 90. which means 90 degrees clockwise. Okay. And if remember for negative 90, I first reflect over the y-axis, xy, reflect over the y-axis becomes negative xy, and then reflected over, that's over y-axis, and then over the line y equals x. And that just switches the x and the y coordinates. So my final answer would be y negative x. Okay, so I can memorize that y negative x as I told you to do, but I also showed you in class how you could draw a triangle and do a rotation from the origin itself with triangles. Okay, just like you're rotating about a point off of the origin, you can do the same thing with using the origin. So I'm not going to do that because I've already shown you that in class, but I'm just going to use y equals negative x as you see written right here, and I just apply that to each point. So a prime becomes y, which is 2, negative x, negative 1. B prime becomes y, which is 3, negative x is negative 4. And C prime becomes y, which is negative 2, and negative x is negative 1. And then I go ahead and reconnect those, and I should get a rotation. So since when you're rotating 90 degrees clockwise, if the points, these 2 points are in quadrant 1, they're going to end up in quadrant 4. So I better have these 2 in quadrant 4. Okay, and then this one was in quadrant 4, rotating it, so it's going to end up in quadrant 3. Okay, so just remember that as a general rule. Whenever rotating 90 degrees, it's going from one quadrant to the next quadrant in whatever direction, in this case clockwise. If it was counterclockwise, it'd go from quadrant 1 to quadrant 2, or from quadrant 4 to quadrant 1. So that's a different, that's just knowing that you better end up in that quadrant for a quick check, you know, if you don't want to do a quick check. All right, next side. State whether the figure is an isometry. Remember, another word for isometry is rigid motion. You need to know that. We've talked about that many times in class. And what are the isometries? Now, remember, that is also different from transformation, because transformation includes the dilation that rigid motions and isometry do not. Because remember, the definition of congruence on the DCAS is that if I can go from the pre-image to the image by any combinations of isometries, in our 4 isometries that we have reflection, which is a single reflection, rotation and translation, which are 2 reflections. Translation is 2 reflections over parallel lines. Rotation is 2 reflections over intersecting lines. Remember, you know those definitions. And a glide reflection is a translation and a reflection for a total of 3 reflections. And don't forget that 1 and 3, so reflection and glide reflection, switch orientation, and translation and rotation, even number of reflections keeps the same orientation. So they remain as, from pre-image to image, their orientation of either clockwise or counterclockwise remains the same. Versus if it was 1 or 3, a reflection or glide reflection, they would switch orientation from clockwise to counterclockwise. I told you if you are in the coordinate plane and they were asking you to figure out, for example, what it was, what happened, how'd you get from the pre-image to image, the first thing you should do is check its orientation if you can't tell right away, and that will wipe out 2 of the 4. So state whether the figure is an isometry. If it's an isometry, we know they're going to be congruent. The simple definition of congruence is same size and shape. Are these the same size and shape? No. So that's quick and easy. Number 12, how many lines of symmetry does a regular pentagon have? So key is it's regular. And whatever that figure is, in this case a pentagon, that's going to be the answer. So a pentagon has 5 sides, so it has 5 lines of symmetry. And that's only because it's a regular pentagon. It would not be the case for an irregular pentagon. All right, 13, what's the smallest angle of rotation that will take a regular, again, that's keyword, and that's how it'll be, they'll all be regular on the DCAS as well, a regular octagon to map back onto itself. The rule is 360 degrees or 360 divided by whatever number of sides that polygon is. In this case, 8. So 360 divided by 8 is 45 degrees. So every time it rotates 45 degrees, it will map right back onto itself. All right, 14. We are doing a proof here that we just got done doing in class. Okay, doing our proofs. Remember, the first step of all proofs is to write down the given. Now, I didn't write the word statement here and didn't do my little vertical segment bar, and I could write reason or justification, same thing. DCAS uses reason now. Okay, but as we talked about in class, reason, justification, same thing. First thing I do is write down my givens. So here's my givens right here. All I do is write them down right there. And I mark them on my drawing if they aren't marked. In this case, they were marked. The angles being congruent right there, and the, I'll change the color here. The angles being congruent there, and those two sides being congruent. The next question I ask myself is, what can I get for free? Is there a side that's in common that I can get for free, or a vertical angle? Well, there is a side, common side right there. So TP is congruent to TP. Now, how do I know which, or I could have said PT is congruent to PT. How do I know which order to write them and make sure they're in corresponding order? I looked right up here and I used theirs right there. See, PT corresponds with PT, or I could have done TP to TP as I did on this right here. And any side congruent to itself, that justification is always reflexive property of congruence, just as any angle congruent to itself. If you use the same angle in two triangles, those are called overlapping triangles, that would be reflexive property of congruence as well. So now I ask myself, do I have enough to prove the triangle is congruent? Yes, I do, by SAS. So now I go ahead and write that order. Now, to make sure I have it in correct corresponding order, I could just go ahead, as I did, is just use, come on, the order that they already have right here. That's what I just did. So triangle STP is congruent to triangle OT. I did switch the order. STP goes with OTP. Okay, so I didn't just use it. I could have used that right there and said triangle SBT is congruent to triangle OPT. That would have been fine as well. And by SAS. Okay. So now I've proven the triangle is congruent. Now I can say any other part that has not been identified here in either the corresponding parts of in the triangles are congruent. So we want to prove that angle S is congruent to angle O. Okay, so again, since it's after proving the triangle is congruent, remember what you're trying to prove is always your last step first off. And since you're doing another corresponding part after proving the triangle is congruent, it's always congruent by CPCTC. And what does that stand for again? Corresponding parts of congruent triangles are congruent. All right, number 15, solve for X. Well, I notice I have an isosceles triangle here, so I should automatically know base angles are congruent by the isosceles triangle theorem. Okay, they gave me that this is 28 degrees down here, and this is a right angle. So I can go 90 minus 28 and get 62 right there. And since base angles are equal, the other base angle must be 62. And 62 and 62 is 124, which is why I have the 124 written right there. 180 minus 124 is 56, which puts it for that angle right there. Okay, that will deal with that. All right, 16. Find the measure of angle 2. Okay, measure of angle 2 is right up here. I'm going to solve for X, but it says the measure of angle 2 is 13X plus 13. Okay, so that we know is right there. Well, I have a linear pair down here. So 180 minus 146 is 34 degrees. Well, if you can't tell, we had an isosceles triangle there. So if that's 34, that base angle is 34, the other base angle is 34. Then I have the vertical angle theorem to move that 34 across right there. And then I see I also have another isosceles triangle right there. So that base angle is equal to this base angle over here of 34. Okay, and then I have a linear pair with that in angle 2. So 180 minus 34 is 146. So I know this is 146 degrees. Now, it didn't say to solve for that angle. It said to actually solve for x. But I know that angle equals 13x plus 13. So I go ahead and set that equal to 146. Subtract the 3 across. 143 equals 13x. Divide by 13 on both sides. And that gives you x equals 11. Okay. More likely it's come out to a nice number like that, probably. All right, 17. Mark the congruent sides and angles. Since there's a triangle, we have 3 angles and 3 sides. I better have 6 pieces marked. The 3 angles and the 3 sides. Remember, B matches up with M. So 1 arc and 1 arc. D matches up with, oops, I thought I changed the color. D matches up with L. So 2 and 2 for D and L. And then lastly, C matches up, corresponds. When I say matches up, that means corresponds. C, 3 of them with K. Okay, now as far as doing the sides, you can go back and look at the congruent statement again. Remember, this is called a congruent statement right there. You've written several of those already in assignments. You got to know it for the test and for the DCAS because they're going to ask you to write a congruent statement then. Okay. I can either look at the congruent statement itself and get my answers, or I just look at, since I've already marked the angles with the arcs, I just go ahead and say, okay, between 1 and 2 on this first one, I'm going to put 1 hash mark. So I have to do between 1 and 2 on this triangle, I have to do 1 hash mark. Okay, so then I just keep going around like that. The next one is going to put 2. I can choose whatever one I want to put the 2. So I chose to put it there. That's between 2 and 3. So that means over here between 2 and 3, I must put 2 hash marks. And lastly would be 3 hash marks on the third side between 1 and 3. Okay, so on this one, it just asks you to mark the congruent sides. If it on the test, it's going to ask you also to write that out in symbols. So I'd be having to go angle B is congruent to angle M. Angle D is congruent to angle L. Angle C is congruent to angle K. That's the 3 angles, and then I have to do the 3 sides. Segment BD is congruent to segment ML. Remember, these are all capital letters. Segment DC is congruent to segment LK. And segment CB is congruent to KM, segment KM. Remember, if you forget the segment symbol, that means the distance between it, and that is wrong. So you're going to do all of this on one problem on the test. You're going to mark them all, and then you're going to write them all out like that. So just know that. That's why I did it here, even though that writing it out wasn't part of the problem. But I'd already warned you that you'd have that on your test to begin with. All right, for 1819, state how you know the triangles are congruent. You must identify the extra piece you were able to get on your own on the drawing correctly. So they gave me these two, and they gave me the right angle symbol, which means it's right angle. So I have an S and an A, and of course then I have reflexor property down the middle there. They share that common side, and now I have SAS. I must see that marked as SAS right there, or you don't get credit. And 19, we had a 1 given to us, a 2 given to us, and again, reflexor property of congruence, the middle side that they share in common now gives me SSS. And lastly, number 20. What additional piece must be given in order to prove the triangle is congruent by the given reason? The given reason right here is ASA. So they gave me this arc and this arc. That's it. or I have to have 3 pieces. Well, I can come up with this on my own, so they didn't have to give me that. That's reflexive property of congruence. So the piece they had to give me were these other 2 angles right here. Okay, 2 arcs. Oops, I thought I changed the color. Okay, so let's erase that right there. 2 arcs and 2 arcs. So now I have ASA. I have to make sure I order that correctly. So I did QCD on the first one, and that matches up with ECD for the corresponding order for the second. Okay, the key is you do it in corresponding order. I could have done DCQ and DCE as well. As long as I do corresponding order, that's good to go. And again, you have to mark that extra piece on the drawing and name it both in order to get your credit on the test. Okay, that goes ahead and explains your practice test. Your test will look just like it, just different numbers and different shapes, different triangles to choose from here and a different proof, but they're all very similar.